Hello everyone. Today let us discuss total sum of interaction cost in tree groups problem. First, let us read the problem statement. You are given an integer n, an undirected tree with n nodes, number 0 to n minus 1. This is represented by 2D array, edges of length n minus 1, where edges I equal to u1 comma v1 indicates an undirected edge between u1 and v1. uh, Here they are saying that we are given a tree. Tree means if there are like n nodes, then there will be n minus 1 edges, and they are saying how they will uh, give that tree structure to us. They are saying they will give tree structure to us by like first they will give n. Okay, so they will give number of nodes of a tree. For example, if they give this tree, they will give like there are like total uh, 7 nodes. Okay, so they will give n equal to 7. Then they will give all the edges. Say like this is like 1 2 3 and so on. So they will give like 1 2 1 3 as and then 2D array. Like they will give n minus 1 such edges, so that we can form a tree. You are also given an integer array group of length n, where group I denotes group label assigned to node I. Two nodes u and v are considered part of same group if group u equal to group v. The interaction cost between u and v is defined as number of edges on the unique path connecting the tree. Okay, here they are saying that in addition to the node number, each each for each node uh, that that belong to a some group. Okay, well, let us think that this group number is like representing color. So we can think that each, in addition to that, each node is kind of colored with another color also. Okay, so they are asking the interaction cost between u and v is defined as number of edges in present in the tree. As we are given tree, between u and v, there will exist an unique path. Okay, in that unique path we need to count the number of edges. That number of edges will be the interaction cost. Return an integer denoting the sum of interaction cost or all unordered pairs u comma v, such that group u equal to group v. So here what they are asking, they are asking to calculate interaction cost for each group, and sum them. Okay, let us understand with this example. They gave n equal to 3 and edges 0 1 1 2 and group equal to 1 comma 1 comma 1. Okay, so this is the example for that. So now we will dry run on this example. They gave us n equal to 3. So like we have a tree like this. This tree can be formed by these edges. That there is an edge between 0 and 1 2. In addition to that, we have a color, like color 1. Okay, so this is with color 1, this is also with color 1, this is also with color 1. Okay, so now we need to find the interaction cost here. So what we need to do, we need to take, say here there is only color 1. So we need to consider all possible edges with pair of vertices with color 1. So 0 1 1 2 and 0 2. How many edges are there in path between like 0 1 1, between 1 2 also 1. Okay, between 0 2 also there are like 2 edges. So answer will be 2 plus 1 3, 3 plus 1 4. Yeah, 4. So say it is very simpler example. Say maybe we have something like this, 3 and like 4. Say here we also say these are colored with colored 2, it is colored with colored 2. So now for this graph, for this tree, it we had calculated for color 1. Now we need to calculate for color 2 also. Like only 3 4 exist, and number of edges in between, unique path between 3 to 4 is like 1. And now answer will be color 1 contribution, which is 4, and color 2 contribution, which is 1. 4 plus 1, 5. Okay, for this modified graph, which is different from input. So now let us think how to approach this question. Okay, so the, the the total colors are making this question complex, but we can observe that the total number of colors will be strictly less than or equal to 20. So it is actually a very low number. So we need to kind of use this low number in for, for our answer. And n is 25, so 10 power 5, so they are expecting an linearish solution. This is the insights we can get from the constraints of the problem. So first let us think how to solve this problem if there is only one color. Okay, then we will try to expand it to like more colors. Say this is the tree and all are colored with the same color. Okay, so all are colored with the same color. So first one is like the brute force way. So what is brute force way? you know uh, get all pair of nodes. Okay, get all pair of start from this node, apply DFS. Okay, then you will get interaction cost to like every node. Okay, similarly from this node apply DFS, from this node apply DFS. Okay, but that will be too time taking, like it will take like order of n square, because we are applying kind of like n DFSs. So but that will of course not pass, because n is like 10 power 5. So could we solve it like more optimally? So let us think in one way. Okay, instead of enlisting all pairs, let us see if for a particular age. Okay, if for a particular age, if for this particular age, like how many pairs of nodes will have this particular age in answer. Okay, how many pairs of nodes will have this edge, will have this edge in the answer. Okay, so like let us let us first think of it. Okay, so it will be nothing but, say this is the size is like V. Okay, and say this whole size is like U. Okay, so number of edges will be nothing but U into V, because you take one node in this from this group of U nodes, and you take another node from this group of V nodes. So how many times this edge will be traversed? This edge will be traversed U into V times, right? uh, so uh, so if we somehow pre-calculate and store U and V, we will simply iterate all edges which are like n minus 1 edges, and we will calculate and sum it. So the so 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 it will be an order of n solution. So but now how to calculate this V, or this V and U? Okay, this V and U can, if we clearly observe, the V is nothing but, uh, for this node subtree size, right? Subtree size, finding subtree size is standard dynamic programming problem. Yeah, so it can be done in order of 1. So in linear time we can pre-compute all subtree sizes. Okay, so now you might ask me, we know V but we don't know U. U is nothing but n minus V, right? Because total are like n nodes. If this is V, then remaining will be n minus V. So this is the main idea. If we have everything with same color. Okay, so if we have everything with same color, then what we will do, we will iterate over all edges. Then we will first we will pre-calculate all subtree sizes. Next we will iterate over all edges and calculate this product u into v. Okay, and then sum it, calculate u and v and sum it. Okay, this will take it will also take order of n, because they are only like n minus 1 order of n edges, right? So this solution can be done in order of n time complexity. Okay, so actually now we have different colors. Okay, now how to handle different colors? Okay, so now let us draw tree for it, example tree. Okay, uh, so these are like two colors. Okay, now uh, so now how to solve this question from the insights we drawed, if all colors are same. Okay, we can solve it. So if we think that in each node we will store similar to subtree size, we will store, say, like blue, how many blue nodes are there. Okay, from this node. Okay, there so it will be like 3 nodes, right? How many yellow nodes are there? Okay, how many yellow nodes are there? 1 2 3 4. Okay, equal to 4. Similarly, we'll store here also, how many blue nodes are there? 2. Okay, how many yellow nodes are there? Okay, yellow nodes equal to 1. Okay, so we can pre-calculate how many blue nodes are there and how many yellow nodes are there in descendants from that node, uh, uh, by using dynamic programming, very similar to how we calculate subtree size. We'll see it in code. Okay, it can be done in like order of n time. Okay, so once we calculate this, okay, now we will populate answer, color by uh, color. Okay, so we will take first all blue nodes, right? After taking all blue nodes, okay, so we will again traverse over all edges. Okay, say we'll see for this edge. Okay, for this edge, how many blue nodes are there at down? Like 2. Okay, so how many blue nodes will be like there in total? There will be like 3 minus 2. Okay, we will also calculate total number of blue nodes and total number of yellow nodes. Okay, so this edge will be coming in like 2 into 1 2 times. Okay, so we can easily see that this edge will come when these two nodes will occur, and when these two nodes also will occur. Okay, so we will similarly do it like for number of colors times. We saw before, number of color times are like is less than or equal to 20. So it will be like 20 into order of 1, which is still order of 1. Okay, it will pass. Okay, so in this also, let us write steps like before. First we will calculate subtree size of each color, okay. It can be done in linear time. Okay, then we then calculate total number of colors. Okay, total colors, like this 3, it will help in calculation. Okay, then for each color, for each color for each color calculate u into v and sum. Okay. So these are the three steps we'll follow. uh, so another observation is that instead of iterating over edges, we can actually iterate over nodes. Okay, so like here, I am saying iterating over this edge. Okay, let me draw it. Okay, iterating over this edge is equivalent to iterating over this node. Okay, right, because iterating okay, we will see the if all colors are same, it will be like more very easier to understand. Okay, iterating over this edge will be equivalent to iterating over this node. Why? Because when you are iterating over this edge, your this is your v and this is your u. Okay, this v is nothing but subtree size of this node, right? And this u is nothing but n minus subtree size of this node. So similarly, if iterating over this edge is equivalent to iterating over this node, right? So instead of iterating over edges, we can iterate over nodes. Okay, this is another observation. Okay, now let us see code. Okay, so what is our first step? Calculating subtree sizes for each color. Okay, so for that, I said as I said before, we will calculate very similar. We will calculate like how we calculate subtree general subtree sizes. We will calculate general subtree sizes by using in-order DP of a tree. So we'll use tree DP here. Okay. Next, I am creating an adjacency list. Okay, so I will convert this edge list in which they gave graph into adjacency list. Okay, then I am doing resize because there are like n nodes, right? Then I am populating the adjacency list here. Okay, then I am this DFS is the tree DP. Okay, so yeah, this is the DFS which will calculate the subtree sizes. Okay, so so when you are so if you are at an, this is the base case. Okay, this is the base case. So if you are at this if you are standing at this node n. Okay, so uh, so this TP is an 2D array. Okay, the as I said before, each node will store how many blue nodes are there and how many yellow nodes are there. Okay, so say this is node number 1. Okay, and blue is say number 0 and yellow is say number 1. Okay, so DP of 1 0 will represent number of blue nodes, uh, number of blue nodes in including node 1 and descendants of node 1. Okay, similarly DP 1 1 will represent number of yellow nodes including node 1 and also descendants of node 1. Okay, so that's why uh, we are doing DP and then labels NN. Okay, labels NN is nothing but this group number. Okay, the group number. I'm calling it as label. See, if it is yellow, then if it is blue, then 0 will activate. Otherwise, yellow will activate. Okay, so DP and then labels and then equal to 1. Okay, then from there we are iterating over the remaining edges. Okay, if v not equal to pp, so that we will don't visit the parent. Okay, because parent is already visited. In DFS we will visit each node on only once. Okay, then I am saying that populate all answers for the children. Okay, populate answer for this node and also populate answer for this node. Okay, the what this DFS does, this DFS populate answer for this node, also answer for this node. Okay, after populating the answer for a node, what I am doing, I am iterating over all the colors. Okay, how many colors we have? We have like 20 colors. Okay, so I equal to 0, I less than 21, I plus plus. Okay, so I am iterating over all colors and I am adding the those colors also. So for example, if we kind of dry run, okay, so here the number of blue nodes at starting will be like 1, okay. So now I am populating answer for this node, okay. So so let us think that DFS calculates number of nodes for this blue node, okay. The number of blue nodes for this will be equal to 2, okay. So what we are simply doing, we are updating DP 10, which is initially 1, we are adding 2, because we also need to add descendant nodes for subtree size, right? So 1 plus 2 will be like 3. Similarly, we will calculate number of blue nodes in this node, which will be like 0, okay. And so again we'll do plus 0, okay. Right. So that's what this statement is doing. This statement is simply adding contribution from the descendants, okay. So uh, so by by this DFS, we will calculate how many blue nodes are there, how many yellow nodes are there in each node, okay. Then I'm creating an frequency array, okay. The frequency array, it will store the total colors, okay. So for I equal to 0, it is simply I am iterating over the groups, okay, groups or labels, and I am checking like how many colors are there, okay. Now let us uh, count the total interaction cost, okay. How to calculate the total interaction cost, okay. How to calculate total interaction cost, as I said before, like uh, edge is equivalent to node, okay. So when I am calculating for edge, for node 0, okay, for node 0, okay, calculating this node 0, actually it is very it actually represents no node, okay. It this no edge, because we have only n minus 1 edges, right? But we have total n nodes, okay. This node will represent no edges, okay. So you can also see, because if v count is like 0, then other will be like one will be 0 and another will be like complete frequency I, okay. So then we'll check what will happen for this node, okay. If we are at this node, okay, then it is equivalent to calculating for this edge, okay. For this edge, I am iterating over all colors, and I am calculating the cost u count into v count, as I described before, okay. And I am summing it, that edge contribution for all colors, okay. How many times that edge will be visited for all colors, okay. Then I am returning the cost, yeah. So this will be an linear solution, okay. It will be order of n into maximum group size, like, which is 20, okay. And you can see that it had passed, okay. Thank you.